Hi everyone, and I hope you are doing really fine. Sorry that I am not visible today. So, what are we going to do today? Now, there are 3 points on which we would be talking about. We are talking about the efficiency. We have talked about efficiency till now, but what is different in this type of efficiency? Because efficiency पे कई सारे questions बन सकते हैं. We can find many questions on efficiency. Basics, difference of days and determine the salary. We have done a bit of basics, but we haven't applied that to the difficult questions. So let us first move towards the concept. Let us understand the concepts. अगर यहाँ पे in this first question, if P is 50% more efficient than Q, so we can write it like this: 150 is to 100. So it would be 3 is to 2. Or you could have applied the method, the direct method of percentage, and we could have got 3 upon 2 directly, as we know that 50% improvement is half improvement. So we could have solved it like this also, which would again get into 3 upon 2, right? 50% I have increased 50% in 100%. So this is how you do it from the percentage method. If you do not know it, do not worry. There is a video provided and we would provide the link later on. So I hope you understand this method, right? This is an easy method. So let's follow this again. Now, if someone is 50% efficient, that we have got that, we can put 100 here and we can put the other person 50% more or less as the value of the other person. So we have found the efficiency here. Now, if efficiency were given in fraction, what would you do? Or if number of days were given, for example, P, Q, and R finish a work in how many days? In how many days? Let us say 3, 6, and 12 days. Right. So how would we find the efficiency of this? We have to find the efficiency of this through just a second. Let me write it. Okay. So we can write it 1 upon 3 here. These were the number of days. So 1 upon 3 here, 1 upon 3 is to 1 upon 6 is to 1 upon 12. Now the only way to solve this is to take the LCM of the denominators as we do in the fraction part, as we did in the fraction part earlier. Now, what would we multiply all this with? We would multiply all these numbers by 12, and hence the ratios would be 4 is to 2 is to 1. Right? I hope this is clear. Now, let us move to this question and do it in a shortcut way. Right? Okay. So how would we do it in a shortcut way? Now, since we have read earlier that efficiency is inversely proportional to the number of days. So let us take some examples here. Okay, if efficiency increases by 2 times, let us say we have 2 times efficiency, right? So what would happen to the number of days? Number of days would become half. I will give an example. Just a second. Okay, I have 20 chocolates to eat. Right? I have planned that I would eat them 2 per day. Okay, now my efficiency is 2 per day. This is the efficiency. Okay, so 2 per day is my efficiency, so I would eat these chocolates in 10 days. Fine. So eating 20 chocolates was my work, and the number of days that I would have needed were 10 days. Now, if I make this 2 times, I couldn't hold myself off, right? And I am going for 4 per day now. Right, I bought some chocolates yesterday and I couldn't hold myself. Okay, it was a born win. Okay, so I ate the whole chocolate in 1 day. I had planned that I would eat it in 3 days. So 4 per day, right? Now I am 4 per day. So what would I do? 20 chocolates I had to eat. So in how many days I would eat them? I would eat them in 20 upon 4, that is 5 days. Right? So these are the number of days. Fine. These are the number of days. This was the work, and this is the efficiency now. So when we increase the efficiency by 2, right, by multiplying it by 2, so the number of days, as you can see here, just a second, I would take another color, right? The number of days, as you can see here, turns to how much? It turns to half, right? When the efficiency was multiplied by 2 or was made 2 times, it turned to half. Similarly, if we would have taken it as, okay, if we would have taken it as, just a second, if we would have taken it as, let us take this second course and make it half. So I would have had the 1 per day efficiency, and it would have taken me 20 days. Now when I have halved this, right, from 10 days, the number of days is becoming multiplied by 2. Right. So seeing this, right, let us move to the question. How would we do the question? Okay. So the question says that P is 50% more efficient than Q. Okay, we already had found the efficiency as 3 upon 2. Now, and together they can complete the work in 10 days. Right, together they can complete the work in 10 days. So together they can complete the work in 10 days, right? Okay. So we had 3 upon 2 efficiency. In how many days P and Q can individually finish the work? Okay. Together they were completing the work in 10 days. So what could we have done? Fine. So if we say that, let us add these all, right? 5 units of work is done in 10 days. So 1 unit of work, as we had seen in the last example, we have to multiply this by 50, right? When the efficiency goes low, right, what have I done? I have just multiplied this by 1 by 5. So I had to multiply this by 5, the last one, right? Not this one. Right, I had to multiply this by 1 by 5, so I had to multiply the other entity by 10. Okay, it is not equal to now 50 days, right? So what could have I done? For example, 3 units is the, so if we multiply it by 3, we have to divide the other entity by 3, right? Okay, so 50 by 3 days would be taken by P, and Q would take, right, 50 by 3. I had to multiply this with 3, 1 unit by 3. And if I would multiply 1 unit by 2, I would take half the number of days 1 unit is taken, right? So I would take 25 days in this scenario. I hope you have got this, right? I have already given you the formula of this question, right? Individually they can finish the work in these number of days. So this is the shortcut that we were looking for. Now let us talk about the long method. How could have we done it through the long method? So doing it by long method, let us see. Okay, we had 5 units as the total efficiency, right? We have seen the efficiency. So 5 into 10 would have been the total work, and P's work would have been 50 upon 3 days, right? P would have done the work in 50 upon 2 days, 3 days, and Q would have done the work in 50 upon 2 days, right? Okay, since the efficiency of Q is 2. So this could have also been used, whichever method suits you, you can use that. But this unitary method is also useful in these terms, right? This is known as unitary method. Okay, so we would do many questions on the unitary method in the future too. So let us move to the next question. Okay, So the next question says that, okay, so we have less number of days here. What are we going to do here? Now this question seems a pretty daunting one, but when you would do it, this is pretty easy. So P is thrice as efficient as Q. So 3:1 has been given as the efficiency, right? Hence is able to do the work in 20 days less. Okay, so the number of days would be reciprocal of this. So we can write the number of days as 1 upon 3. So these are the number of days. Fine. Now, what are we going to do? What are we going to do? We are going to write, okay, these as the difference of these units, right? Number of days. So again, we are taking the 2 units as the difference of days. Now we are dealing with days, remember that, which is 20 days. Now, 1 unit would be how much? 10 days, right? 1 unit of work would be done in 10 days. Okay. Now here, remember, we are not dealing with these number of days. We are totally dealing with the number of days. We are not dealing with the efficiency. So number of days does the work in this fashion. Okay. Otherwise, we could have taken this as, okay, the number of days. So we have known that, okay, 3 times days would be taken by Q and P would be taking 1 day. So you could have, okay, yeah, so you could have done the difference. You could have taken the difference. I hope you understand this, right? Okay, you could have taken the difference, 2 units and 1 unit has been given. So 1 unit is 10 days. Fine. Now we have found that 1 unit of days is 10 days, right? So what can we do? Find the time at which P and Q can complete the work individually. Okay, so individual number of days is taken by P as 1 unit, that is 10 days. Okay, and P takes 10 days and Q takes 30 days to do the work. This is the answer, right? This is the answer. So these are fairly the concepts of ratio and proportion, not work, but there is a tinge of information that we need to apply in time and work to do these questions. Now, the next question. These were pretty easy ones, right? Okay, so this is the question. Now we would learn something out of this. So A takes 15 days, B takes 18 days, right? Okay, now let us do this work, right? Okay, I would make this diagram. I would take work here, right? I'm not making the table right now. This is the second way I could have done this. So I would write the efficiency here, and A takes how many days? 15 days, and B takes 18 days. So the efficiency of these people would be 5:6, right? 6:5 would be the efficiency. 18 is 90, 15 is 90. So we would do the work as 90 units. So I would rub this out here and we would do the work as 90 units. So you can remember this diagram and then do the questions accordingly. Now, with the help of C, all of them complete the work in 6 days. Now, C's data is also there, right? This was A, this was B, this is C. So, with the help of C, they all complete the work in how many days? 6 days. Now, the efficiency would be 15, right? 15 into 6 was 90. So, 6 into 15 would be. Now, this is the efficiency of A plus B plus C, right? So, we would write A plus B plus C here. So, we have the diagram ready, right? Now, what would you do? This is the efficiency of A plus B plus C. Now, they receive 18,000 total work. So, we have to find the amount that C gets. We have to find the efficiency of C, right? Efficiency of C, right? So we have to find this. Now let us find this with the red pen. Okay, now 18,000, right? A plus B plus C. The efficiency of A plus B plus C is coming as 15, right? Okay, now and A plus B plus C is coming as 15. 5 and 6. Okay, now 5 and 6 were the efficiencies of B and C. So 6 and 5, I'm writing 6 and 5 here, and C would get 15. So 11 plus C equal to 15, and we would get the efficiency of C as 4. Now when he is taking 4, so we have to find the ratio of work that he has done. So 4 upon 15 would be the total work, and since we are getting 18,000, okay, so let us see where we can get from here. 5 3 5 and 6 3 6,000 would be the answer, and this would turn into 1200. Now 1200 into 4 is 4800. Now C would take 4800 rupees out of this. Remember, whenever the salary question comes, you have to find the, okay, receive rupees 80,000 18,000, so you have to find how much work they have done, and this step is really important. Which step is really important? This step is really important. So this is the way in which you can do this work, okay, in which you can get this work done or get the amount which C gets. Always remember, the efficiency is responsible for the amount you get. Okay, now let us move to the next question. Now this is a difficult question. Try it out once. Try it out once. How would you weave a shawl in 2 hours, 3 hours, and 4 hours respectively? Right? It is known that even being a joint contractor, even each one weaves his own shawl completely. Try it out first, right? We have learned enough till here, so try it out once. Don't get afraid of the question, right? Now let us look at this question. What would have happened had we used the simple method here, right? Okay, so how to first interpret this question? We would do it first with the method that is requisite here, that is required here, right? Now 2 hours, 3 hours, and 4 hours, right? Okay, now we have efficiencies such as A, B is to C would be 1 upon 2 is to 1 upon 3 is to 1 upon 4, right? That is why they are making one shawl in. Okay, so we have one work of making one shawl. Okay, now what can we do with this? We can do only one thing, that is we can take the LCM and we can see how many shawls are they making in 12 hours, because this would simplify the question. So how are we simplifying the question? Let us, okay, make all of them 12. We have to multiply these numbers with 1 also, right? And we would have got 13 shawls. In this way we would have got 13 shawls in 12 hours. Okay, so we could have got to 91 shawls in this way by multiplying 13 by 7 in 12 into 7 hours, right? So we could have got 91 shawls in 84 hours. Now how to proceed? That is the problem, right? We have, there is a scope of error here. Now what are we doing here? We are following the scope of error. Okay, now we have to keep an eye on how each and every one works. Now let us add another 4 hours here, right? 4 hours. I'm using the least amount of work because C is doing the work in 4 hours. Now in 4 hours they would do 2 plus 1 shawl. Remember, A has made 1 upon 3 more shawl right now, okay, in 1 hour. So this is a suspicious activity here. 4 hours more, they would have got 2 plus 1 plus 1. Now P has got another 1 upon 3 work done, right? So he has made 2 upon 3 shawl already, right? 1 upon 3 work done here, another 1 upon 3 work done here, right? Okay, so he has already made 2 upon 3 shawls, that is 1 upon 3 plus 1 upon 3. Now he only needs to do 1 upon third of work, which he can do in 1 hour, Total number of hours that we are having is 4 plus 1, right, plus 1 and plus 91. So the total number of hours that we are having is 91 plus 4 plus 4 plus 1. Remember, here you would make a mistake. If I would show you the option, you would make the mistakes here. So this is the counting method that you need to employ here. So we would be taking, sorry, this was not 91, this was 84, right? This was 84, right? This was 84 plus 4 plus 4, 1, right? Okay, so we are taking total of 93 hours to do the work. This is the final answer. Right, this is the fun answer. This was a complex set. So I have told you, you can take different LCM methods, right? You can take LCMs whenever you can use, you see, but you have to interpret that in this language. You have to interpret this in this language, right? Okay, that is all for this topic, right? We would be doing different kind of efficiencies, different kind of works when different type of people are involved, right? We have to take different kind of efficiencies in that. So those complex sets would be involved in the next chapter, okay, in the next video. Till then, enjoy and keep on practicing.